You can't just apply every clean code principle you know and expect your code to be clean. Clean code has a formula, and in today's video I'll break it down to you step by step. So let's jump in. This formula has 3 factors on the top and 2 factors on the bottom. The top ones boost your clean code score, while the bottom ones drag it down. We'll start with the first factor, readability. Code should speak for itself. If you don't need someone to walk you through the code to understand it, that's high readability. That's why relying on comments is discouraged. Code shouldn't rely on comments to explain it, it should explain itself. Why? Because comments lie, code doesn't. Comments go outdated, code shouldn't. And for every line of comment you add, that's one more thing you have to maintain. I gave this one a weight of 0.9 and not 1 because sometimes the code is complex by nature. For example, if a beginner is reading a quicksort algorithm for the first time, it wouldn't be that easy to read and understand. But in such cases, an expressive test suite can act as documentation instead of relying on comments. The second factor is consistency. Consistency makes your code feels predictable. It's about keeping the same habits, consistent formatting, naming, and structuring of your files in your code. Inconsistent code slows you down. You start second-guessing things like, are we using lowercase or camel case for variables? Every small difference adds friction. That's why teams use style guides or linters, not to be strict, but to reduce the mental friction. I rated this one 0.6 because inconsistency isn't a deal breaker. In real projects, we keep adopting new ways to write code, and that naturally makes things a bit uneven. And that's totally normal. It doesn't really hurt your work. The third factor is cohesion. Cohesion means everything inside a class or a module should work towards one clear purpose. Each part should belong there. No random methods doing unrelated work. A simple rule of thumb is to check how many fields are used by how many methods. For example, in a class, if all the fields are used by all the methods, that's maximum cohesion. But if none of the fields is used by any of the methods, there is no cohesion at all here. That's a bunch of unrelated methods put together. I gave this one a weight of 0.8 and not 1, because in real life, full cohesion is a bit rare. For example, we might have utility classes or framework integrations, and that's fine. Chasing full cohesion might lead to over-engineering. By the way, if you enjoy learning about clean code and would like more content like this that you can directly apply in your work, I share more practical tips through my free email list. So if you're interested, link is in the description below. Now for the first denominator, coupling. Coupling measures how different things in your system depend on each other. The more the things are connected, the harder it is to reuse them or change them. When one small change forces you to update several unrelated files, that's high coupling. And when it's easy to do a change without doing unnecessary changes somewhere else, that's loose coupling. And that's what we aim for. I rated this one 0.7 because you can't build real systems with zero coupling. Classes will always need to depend on other classes. And the goal isn't to eliminate coupling, it's to manage it so that change is predictable and contained. Now the second denominator is gold plating. Gold plating happens when you make big decisions today without enough data to support it. It's not about thinking ahead, that's good by the way. It's about acting on assumptions that you haven't validated yet. For example, you might build a whole plugin system before you know if you will ever need more than one plugin. I rated this one 0.9. because over-engineering can undo most of the benefits you gained from readability, consistency, and cohesion. The code works, but it becomes harder to understand and change as real requirements evolve. It's okay, even smart, to think about the future. Just don't act on guesses. Gather data first, then refactor your code with confidence. So, by now you might understand the whole clean code formula. But you might still be asking yourself, how do I actually increase this score? How do I practically apply this? But that's actually a detail. As I have told you before, I can send you practical tips through my email list, and you can find a lot of clean code principles online. The important thing is to understand this formula, because then you will be able to understand what boosts the score and what drags it down. You shouldn't consider those clean code principles religious beliefs and apply them no matter what. Instead, you should understand them and take a conscious decision whether you want to apply them or not. Clean code is actually one piece of the puzzle. If you're serious about leveling up as a developer and would like to know what to learn next and in what order, I break it all down in my video, the exact roadmap to level up as a developer. So check it out next.